Find the area bounded by this curve and the x-axis. So that's really, if we need to get a feel for this curve, don't we? So we better give a quick sketch of it. And then we'll see what's what. So let's do it. There's the x. I'm just doing a rather crude sketch here. Now I'm going to need to factorize it, because I know, because this is positive, it's going to be a U-shaped curve rather than an N-shaped curve. So we know that. But we also, if we factorize it, then we can see where it equals naught, and we can then draw the curve more accurately. So here, x and x, 5 2's with a minus and a minus, isn't it? So we can see that when y equals 0, x minus 2 is 0, so x is 2, and when this is 0, x is 5. So if we mark off those points, 2 and 5, we know it's a U-shaped curve because this is a positive x squared, so it's going to, and when x is 0, 0, 0 and 10, so it's going to come down from 10. So come down here. I'm doing a dashed line because it's a digital pen. It's going to turn and go back up like so. So the area, if we were drawing a slightly bigger picture now, bounded by the curve and the x-axis, it corresponds to this area here, doesn't it? I'll just put an arrow in it. There's the area in question. So here the area then is equal to. Now the point is, we said before that the area was integral y dx, and that's true, but that's only true in this scenario here. When a curve is below the axes, like so, say, and this is the area, because y is negative, we have to introduce a minus, so area is equal to minus integral y dx between the bounds a and b. So that's a new bit of bookwork. If it's above, it's positive, the integral value, and if it's below, because the y's are all negative, this value itself will be negative. Areas are always positive, so you have to put a minus in to make the whole value positive. So if ever you get an area coming out as negative, you know you've probably not noticed the fact that it's under the curve. So here we need to do the integral, this area between 2 and 5, and we need to put a minus in, don't we? So that's the integral, and that's easy forgotten, but there's an easy check at the end. So x squared minus 7x plus 10. So let's worry about this problem now then, how we've done the process. X cubed over 3 minus 7 raised to the power by 1 divided by that number. Constant integrates to constant times x. It's a definite integral between the bounds 2 and 5 and the minuses at the front. So what have we got? We got minus top value, take bottom value. Put 5 in, 5 cubed over 3 minus 7 times 5 squared over 2 plus 10 times 5 minus the bottom value, 2 cubed over 3 minus 7 times 2 squared over 2 plus 10 times 2. So minus bracket 125 over 3 minus 25 times 7 is 175. Tap these numbers in the calculator if you need to, plus 50. 725 so 175. 8, 2 cubed is 8 over 3 with a minus. I'm running the minus through. Minus 8 thirds. Minus and a minus is a plus. One of the 2's cancel, we get 14 then, 7 2's. And minus 20. So, almost there. Let's just do a bit more before we need to tap in the calculator. Minus 8, 125 minus 8 is 116, isn't it? 117. 117 over 3. And then minus 175 over 2, which we could write as 85 5, 87.5 if we wanted. I'm going to write it as 87.5 now, because I'm doing it by hand rather than using a calculator. 14 minus 20 is minus 6. 50 minus 6 is 44. Okay. Okay, so let's have a look at this. We've got 39 here. So I'm not going to use a calculator because I haven't opened it. So I'm just going to 39 plus the 44 minus 87.5. 39, 79, 83. 83 minus 80, minus 4.5, so it becomes plus 4.5, doesn't it? So use a calculator if you need to on these calculations.